Welcome aboard Cosmic Compass, where we explore the distant edges of space, decode the forces that shape our universe, and tell the stories written in the stars. In this episode, we're travelling to the most remote planet in our solar system, a place of violent winds, vanishing storms, and a mysterious glow in the darkness. Neptune, cold, far, and full of contradictions. You may never see it with your own eyes, but today we'll bring it closer than ever before. Let's begin our journey. Look up into a clear night sky. You may see stars, perhaps the moon, even the faint glimmer of Mars or Jupiter. But there's one planet you'll never see, not with the naked eye. It hides in the outermost shadows of our solar system. That planet is Neptune, invisible to our eyes, yet astonishingly alive. While it may seem distant, cold, and forgotten, Neptune is in many ways one of the most extreme worlds we've ever discovered. So why is a planet nearly 5 billion kilometers from the Sun, where sunlight is 900 times dimmer than on Earth, bursting with activity, what drives its furious winds, its chaotic storms, and its mysterious internal heat? Let's embark on a journey to uncover the secrets of this distant ice giant. Neptune wasn't discovered through a telescope. It was predicted, calculated before it was ever seen. In the early 19th century, astronomers noticed something odd. Uranus wasn't behaving. Its orbit didn't match predictions. Something was pulling on it. But what French mathematician Urbain Le Verrier ran the numbers and concluded there must be another unseen planet beyond Uranus. In 1846, German astronomer Johann Galle pointed his telescope at the sky exactly where Le Verrier told him and found Neptune just 1 degree away from the predicted location. A few days later, its largest moon, Triton, was discovered. It was a discovery that combined human curiosity, reason, and mathematics, an example of science at its most elegant. For the next 140 years, Neptune remained little more than a blurry dot in the sky. Its great distance from Earth, about 30 astronomical units or 4.5 billion kilometers, made it difficult to observe from the ground. But in 1989, everything changed. NASA's Voyager 2 flew past Neptune, becoming the first and only spacecraft to visit the planet. In that single flyby, we discovered that Neptune had rings, intense storms, and a host of previously unknown moons. A planet once known only by math now had a face and a personality. Neptune is the 8th and farthest planet from the Sun. At 30 times Earth's distance, it takes a staggering 165 Earth years to complete one orbit. Since its discovery in 1846, Neptune has only now completed a single Neptunian year. Unsurprisingly, it's bitterly cold. The average atmospheric temperature hovers around 200 Celsius, and yet its axial tilt at 28 degrees is remarkably similar to Earth's. This means Neptune also has seasons just like we do. But there's a twist. Each season lasts for over 40 Earth years. Currently, Neptune's southern hemisphere is experiencing summer, and something curious is happening. During this extended Neptunian summer, astronomers have noticed that the southern hemisphere has become brighter. This unexpected glow suggests subtle interactions with the Sun despite the enormous distance. You might ask, how can sunlight so weak, this far out, still influence the planet? And yet it does. Even a small temperature increase just 10 degrees Celsius is enough to change Neptune's atmosphere. In the southern hemisphere, that's exactly what's happening. The slight warming releases frozen methane from the deeper layers, allowing it to rise into the upper stratosphere where it reflects more light. It's a delicate balance, frozen gases, solar energy, and chemistry all playing out over decades. If you think Neptune is a silent frozen wasteland, think again. The planet is home to the fastest winds in the solar system, reaching speeds of 260 kilometers per hour near the equator. That's almost twice the speed of sound. Even more curious, the winds mostly blow against the direction of the planet's rotation. These retrograde winds combined with high-pressure systems create violent atmospheric bands. Let's pause and imagine if you stood on Neptune's clouds somehow surviving, you'd witness a planet where wind and storm rule with unmatched fury. When Voyager 2 visited Neptune, it spotted a storm as large as Earth. It was called the Great Dark Spot, a swirling vortex like Jupiter's Great Red Spot. But a decade later, the Hubble Space Telescope looked again, and it was gone. Unlike Jupiter's eternal storm, Neptune's storms come and go, sometimes changing location or disappearing entirely. New ones form, bright high-altitude clouds appear and vanish. It's a planet of weather chaos, and we still don't fully understand the mechanisms behind it. Neptune and Uranus are often called sister planets. They're similar in size, mass, and composition. But why does Neptune have such dynamic weather, while Uranus seems relatively calm? Both are far from the Sun. Both have cold atmospheres, and yet Neptune is more active. The answer may lie beneath the clouds. Unlike Uranus, Neptune emits more heat than it receives from the Sun. Something inside is still radiating energy. Uranus, in contrast, is oddly silent, radiating almost no excess heat. One theory, Uranus may have suffered a giant collision early in its history, knocking it sideways and bleeding away its internal heat. Neptune, by contrast, may still be glowing from within. So what is Neptune made of? Its atmosphere is mostly hydrogen, 80%, and helium, 19%, with traces of methane, the gas that gives Neptune its deep blue colour. Beneath that lies a mantle of ices, water, ammonia, methane surrounding a rocky core. And then comes one of the wildest theories in planetary science, rain made of diamonds. At the immense pressures deep inside Neptune, millions of times higher than Earth's atmosphere, methane molecules might break apart. Carbon atoms could bond into crystals, forming diamond hailstones that fall through a liquid carbon ocean. It sounds like science fiction. But researchers have recreated similar conditions in labs, and it's entirely possible that Neptune is raining diamonds. Neptune's magnetic field is one of the strangest in the solar system. It's tilted 47 degrees off its rotational axis and offset from the planet's centre. At first, scientists thought this was linked to Uranus's extreme axial tilt, but Neptune, with a more normal tilt, exhibits the same magnetic weirdness. This suggests that Neptune's magnetic field isn't generated by a core like Earth's. Instead, it may come from the electrically conductive ice mantle, a dynamic sloshing layer surrounding the core. The result, a magnetic field that twists and warps in space. Even Aurora exist on Neptune, though they're invisible to the human eye, appearing as SAR arcs, faint electromagnetic whispers caused by solar particles interacting with the tilted field. Neptune has rings, though you'd barely notice them. There are 5 known rings, Gal, Leverrier, Lassell, Arago, and Adams, named after astronomers who contributed to Neptune's discovery. These rings are faint, dark, and dusty, unlike the bright rings of Saturn. Most curious of all are the arcs within the Adams ring, bright clumps of material that haven't spread out evenly. Normally, planetary rings tend to smooth themselves over time, so what's keeping these arcs intact that remains a mystery? Neptune has 14 known moons, all named after sea gods and spirits from Greek mythology. The most famous is Triton, a world that defies expectations. Triton orbits backward against Neptune's rotation. It's also highly inclined, suggesting that it didn't form alongside Neptune, but was captured, possibly a dwarf planet from the Kuiper Belt. Triton is larger than Pluto, has geysers, an atmosphere, and a stunning burnt orange surface. It may even be the origin of Neptune's rings, formed from disrupted moons when it was pulled into orbit. Then there's Proteus, an oddly shaped moon with huge craters, so large they prevented it from forming into a sphere, and Samatha, and Neptune's outermost moons take 25 years to complete one orbit, the most distant satellites of any planet. Why? Because Neptune's hill sphere, its gravitational reach is vast. So far from the Sun, Neptune can hold onto moons at incredible distances. Neptune is a world of contradictions. It's far yet full of movement, cold yet internally warm, shrouded in darkness yet bursting with storms and mystery. We can't see it from Earth, and yet we've learned so much from math, from spacecraft, from relentless curiosity. And still there is more to learn, more to explore. Neptune isn't just another planet. It's a symbol of how much we still don't know and how far we're willing to go to find out. From its diamond rains to its tilted magnetic field, from captured moons to chaotic storms, Neptune reminds us, even in the coldest corners of space, the universe is alive with motion, mystery, and meaning. If this journey sparked your curiosity, there's more ahead. Subscribe to Cosmic Compass and stay with us as we continue to navigate the wonders of space, one planet, one moon, one question at a time. Until next time, keep looking up. The cosmos is waiting.